In this video, we are going to talk about integration by parts. So let's assume that we have a product of two functions, which is v of x and then u of x. And then let's assume that we want to differentiate these two products. Now, using quotient rule, this is the same as you keep v of x, then you differentiate u of x. If you differentiate u of x, you get u prime of x. Then you add it to. So we are using chain rule in this case. You differentiate v of x to get v prime of x. Then you multiply by u of x. Now, the function we are trying to integrate is of the form v prime of x, u of x. So let's make v prime of x, u of x the subject. So this becomes v prime of x, u of x equals. So all of this is the same as v of x, u of x prime, then minus v of x, u prime of x. Now let's integrate all. So if we integrate, we are integrating everything. So we are integrating v prime of x, u of x, and this is equal to the integral of v of x, u of x prime, then minus integral of v of x, u prime of x. So integral of, but because we are integrating, all the functions are defined in terms of x. So this is the same as integrating over x. So that is dx. So we can say this is the same as integral of u div, and this is equal to, now if you integrate v of x, u of x prime is the same as v of x, u of x minus integral of, this is the same as v du. So this is the formula when it comes to integration by parts. Evaluate integral of the product of x and exponent 2x dx. So if you look at these two functions, that is, in this case, you can see that v of x is x, and then u of x is exponent 2x dx. So you can see that we can easily integrate exponent 2x, and then we can easily differentiate x. So in this case, what we will do is that we will remember the formula for, let's first write down the formula. The formula is integral of u div equals uv minus integral of v du. So in this case, what we will do is that we are going to we can easily differentiate x, and we can easily integrate exponent 2x. So let's let u to be equal to x. So du in this case is equal to dx. And then let's let div to be equal to exponent 2x. So v in this case is equal to, now you first differentiate what is in the exponent. So if you differentiate 2x, it is 2. So 1 divided by 2 exponent 2x. So that is v. Then we can put it in this formula. So integral of x exponent 2x dx is equal to u is x, and then v is times 1 over 2 exponent 2x, then minus integral of v du. Now du is the same as dx, then v is half of exponent 2x, then du is dx, so dx. So this is equal to half x exponent 2x minus, I'm bringing half out, integral of exponent 2x dx. So this is equal to half of x exponent 2x minus. Now if you integrate this, you get 1 over 2. 1 over 2 times 1 over 2 is 1 over 4 exponent 2x, then plus the constant of integration, which is c. So we also have another example here, which is to integrate x cos x dx. So you see that if we can easily differentiate x and we can easily integrate cos x. So because we can easily differentiate x, so we need to let u to be equal to x, so that the u will be equal to dx. And then the one we can easily integrate, that one becomes the vn. So the vn is equal to cos x. So vn, if you integrate cos, you are going to get the sine function. So if you integrate cos x, it's equal to sine x. So vn is equal to sine x. And then the formula says that integral of u dv is equal to u vn minus integral of vn du. So integral of x cos x dx is equal to u is x, and v is sine x. This is v. Then minus integral of v, which is sine x. Then the u is what? Dx. So integral of sine x dx. So this is equal to x sine x. Then minus, if you integrate sine x, you will get minus cos x. Then plus the constant of integration c. So this becomes x sine x, then plus cos x plus c. Evaluate integral of exponent x sine x dx. So as for this one, let's let I to be equal to the integral, which is integral of exponent x sine x dx. Now in this case, you see that we can easily differentiate sine x, and then we can easily integrate exponent x. So let's let u to be equal to sine x. So du is equal to cos x dx. And then let's let the v to be equal to exponent x. So v, if you integrate exponent x, you are going to get back the same thing, which is exponent x. So the integral, which is I, but let's write the formula. So integral of u dv is equal to u v minus integral of v du. So integral of u dv is the same as I, which is equal to u v. U is sine x, and v is exponent x. So we have sine x exponent x minus integral of v, which is exponent x, and then du is cos x dx. So exponent x cos x dx. Now what we need to do further is to integrate this aspect too, which is the integral of exponent x cos x dx. So this one too, we need to take that aspect too through another integration by parts. So let's differentiate cos x, but let's let u to be equal to cos x. So du is equal to minus sine x dx. And then let's let the v to be equal to exponent x. So v is equal to exponent x. And then the formula is integral of u dv is equal to u v minus integral of v du. So this is equal to u v, which is u is cos x and v is exponent x. So exponent x cos x, then minus integral of v du. V is exponent x, and then du is minus sine x. So this becomes exponent x times minus sine x dx. So this becomes exponent x cos x, then plus integral of exponent x sine x dx. So let's take all of this and insert it here. So I is equal to sine x. So exponent x sine x, then minus the integral of all of this is exponent x cos x, then plus integral of exponent x sine x dx. So let's remove the bracket. So I is equal to exponent x sine x, then minus exponent x cos x, then minus, now see, we started with exponent x sine x dx, and we said that is I. It's the same thing here, exponent x sine x dx. So minus I. So if we bring this I here, it becomes 2i, making I the subject. So 2i is equal to, now let's factorize exponent x out. So exponent x times sine x minus cos x. So making I the subject, I is equal to half of exponent x, then times sine x minus cos x, then plus, then constant of integration c. So this is the answer for that integral. We are supposed to evaluate the integral of tan inverse of x dx. Now, to be able to do this integration, you see that we cannot easily integrate tan inverse of x dx. So that means that what we can do is that we can differentiate tan inverse of x dx. Then this is multiplied by 1, because 1 times tan inverse of x dx is the same as tan inverse of x dx. So we can integrate dx and then differentiate tan inverse of x. So let's let u to be equal to tan inverse of x. The u, if you differentiate tan inverse, is the same as 1 divided by 1 plus x squared dx. Now, I've already done a video on how to differentiate the inverse trigonometric functions. I would link that video in the description so you can watch that to understand how to differentiate the inverse trigonometric functions. So now, having done this, then let's let v to be equal to, the v to be equal to 1. So it implies that v is equal to x. Now, the formula is integral of u dv is equal to uv minus integral of v du. So integral of tan inverse of x dx is equal to u. U is tan inverse of x. V is x. So it becomes x tan inverse of x minus integral of v. Now, this our v is x. Then times the u. The u is 1 over 1 plus x squared dx. So divided by 1 plus x squared dx. Now, you see that if we differentiate the denominator, if we differentiate 1 plus x squared, we will get 2x, but we only have 2 here. So what we will do is that this is equal to x tan inverse of x minus, now I want to put 1 over 2 here and push 2 into the numerator so that this becomes 2x. Now remember, 1 over 2 times 2 is the same as 1, so we have not really done anything. Divided by 1 plus x squared dx. So you see that if you differentiate the denominator now, you differentiate 1 plus x squared, you get 2x. So we can use the natural log. So this is equal to x tan inverse of x minus half natural log of the absolute value of 1 plus x squared, then plus the constant of integration c. So we have this question here, which is to integrate into bracket x squared plus x, then times exponent 2x dx. So what we need to first do is to expand the bracket. So this is equal to integral of into bracket x squared, then exponent 2x, then plus x exponent 2x dx. Then we use the principle of integration to break this integral into 2. So this integral becomes integral of x squared exponent 2x dx, then plus integral of x exponent 2x dx. So this is equal to, let's let u to be equal to x squared. So du is equal to 2x. Now let's let the v to be equal to exponent 2x. So v is equal to 1 over 2 exponent 2x. So the formula is integral of u dv equals uv minus integral of v du. So this becomes uv. U in this case is x squared. Then v is half. So half x squared, then exponent 2x minus integral of v, which is half exponent 2x du. Du is 2x. So it's the same as 2x times 1 over 2 exponent 2x dx. But remember, we are left with this term, which is plus exponent x exponent 2x dx. So this half and this 2x will cancel. So this becomes half of x squared exponent 2x, then minus integral of x exponent 2x dx, then plus integral of x exponent 2x dx. So you can see that here is x exponent 2x dx. Here is also the same thing. So this part goes to 0, and therefore we are left with half x squared exponent 2x, then plus the constant of integration c. So it implies that integral of x squared plus x exponent 2x dx is equal to half of x squared exponent 2x plus the constant of integration c. Evaluate integral from 0 to 1 of x cubed tan inverse of x dx. So in this case, we can easily differentiate tan inverse of x, and we can integrate x cubed. So let's let u to be equal to tan inverse of x. So du is equal to 1 over 1 plus x squared dx. And then let's let the v to be equal to x exponent 3. So v is equal to 1 over 4 x exponent 4. So the formula is integral of, u dv is equal to uv minus integral of v du. So this integral becomes, which is integral 0 to 1 of x exponent 3 tan inverse of x dx is equal to u tan inverse of x, then v 1 over 4 x exponent 4. So 1 over 4 x exponent 4, then tan inverse of x, then minus integral of v, which is this, then du. Du is 1 over 1 plus x squared dx. So this becomes 1 over 4 x exponent 4 times 1 over 1 plus x squared, then dx. So the integral becomes, so this is equal to 1 over 4 minus, 1 over 4 x exponent 4, then tan inverse of x. Now let's pull out 1 over 4. 1 over 4 integral of x exponent 4 divided by 1 plus x squared dx. So this was where we reached. We reached 1 over 4 x exponent 4 tan inverse of x evaluated at 0 and 1 minus 1 over 4 integral of 0 to 1 of x exponent 4 divided by x plus x 1 plus x squared dx. Now let's solve this. If you put in 1 exponent 4 is 1. So we have 1 over 4, and then 1 exponent 4 is 1. Tan inverse of 1 is 45 degrees. 45 degrees is the same as pi over 4 radians. Then if you put in 0, because of this x, that part will go to 0. So minus 1 over 4, integral of 0 to 1. Now, I want us to add and subtract 1 on the numerator. Plus 1 minus 1 is 0. So we've done nothing to the function in essence. So this becomes x exponent 4 plus 1, then minus 1 divided by 1 plus x squared dx. So this becomes pi over 16 minus 1 over 4. Integral of, I want us to break the integral into 2. So x exponent 4, which is this one, minus 1, divided by x squared plus 1 dx. And then plus 1 over 4, integral of 0 to 1, of 1 divided by x squared plus 1 dx. So this becomes pi over 16 minus 1 over 4, integral of, now this can be written as difference of two squares because x exponent 4 is the same as x squared all squared. So this is the same as x squared minus 1 times x squared plus 1. Because it's difference of two squares, x squared times x squared is x exponent 4. The minus 1 times plus 1 is minus 1. So we get back what we started with, divided by x squared plus 1 dx. Then plus 1 over 4, integral of 0 to 1 of 1 divided by x squared plus 1 dx. So this becomes pi over 16 minus this part and this part can cancel out. So we are left 1 over 4 integral of from 0 to 1, from 0 to 1. This place 2 is the same, of x squared minus 1 dx. And then plus 1 over 4 integral of 0 to 1 of 1 divided by x squared plus 1 dx. So this is equal to pi over 16 minus, if you integrate x squared, you get, this is 1 over 4, then times. If you integrate x squared, you get 1 over 3 x exponent 3. And if you integrate minus 1, you get minus x. All of this evaluated as 0 and 1. Then plus 1 over 4. Now, 1 divided by x squared plus 1 dx, if you integrate this, is the same as tan inverse of x. So this is tan inverse of x evaluated at 0 and 1. Now, this is pi over 16 minus 1 over 4. Now, if you put in 0, it will go to 0. But if you put in 1, 1 cube is the same as 1. 1 times 1 over 3 is 1 over 3. So here becomes 1 over 3 minus 1, then plus 1 over 4. Now, if you put in 1, tan inverse of 1 is 45. 45 degrees is the same as pi over 4 radians. Then if you put in 0, tan inverse of 0 is 0. 1 over 4 times 1 over 3 minus 1 is the same as minus 2 over 3. And then plus pi over 16. So this becomes pi over 16, then plus 2 over 12. 1 over 6, then plus pi over 16. Sorry, I made a mistake here. Now, because here is minus, the minus affects everything. And because the minus affects everything, here's minus 1 over 4. This place is also supposed to be minus 1 over 4. Likewise here. So all of these terms is going to be minus. So here is also minus. And then here is also minus. So this pi over 16 is minus pi over 16. And therefore this goes to 0. And this is equal to 1 over 6.